Problems on Butterworth approximation. A digital filter has frequency specification as passband frequency 0.2 pi, stopband frequency 0.3 pi. What are the corresponding specifications for passband and stopband frequency in analog domain? If impulse invariance technique is used for designing, and second is bilinear transformation is used for designing. So assume sampling time Ts is equal to 1. So for impulse invariance method, we have is equal to Wp by Ts. Therefore it is equal to 0.2 pi 0.63 radian per second. And it is equal to by Ts. Therefore 0.3 pi by Ts, it is 0.3 pi. Therefore it is equal to 0.94 radian per second. Now second part of the problem is for bilinear transformation. We write here for bilinear transformation we have it is equal to 2 by Ts tan of by 2. So we replace the values. It is equal to 2 tan of, as Ts is equal to 1 second, we have assumed it is 0.2 pi by 2. So 2 tan 0.2 180 by 2. So its value is 0.65 radian per second, and it is equal to 2 by Ts of tan of by 2. 2 tan of 0.3 pi by 2. So 2 tan of 0.3 into 180 by 2. So its value is 1.019 radian per second. Next problem was asked for 10 marks in exam. Using BLT, that is bilinear transformation, design a Butterworth filter which satisfies the following condition, that is 0.8 h of e raised to j omega is in between 0.8 to 0.1 and h of e raised to j omega is less than equal to 0.2. So we write here h of e raised to j omega is same as h of omega, its magnitude. So the specifications are given for the required digital filter. These specifications we have to show by using figure. So this specification we will show in this figure. And it is magnitude e raised to j omega. This is 1. This is omega p, that is 0.2 pi. It is omega s 0.6 pi. This is 0.2. It is 0.8. This is pass band. This is stop band. This is pi. This is transition band. These are the desired characteristic. So from given specification, we write here given specification of digital filter as AP is 0.8. This is AP. It is 0.2 pi. AS is 0.2. This is AS. And omega S is 0.6 pi. Now first part of the problem, we write here part A, that is calculating specification of analog filter. Calculating specification of analog filter. So in that, step 1 is you will obtain values of these two. So we have to use a bilinear transformation method. So for bilinear transformation, we have, it is equal to 2 by Ts tan of, therefore 2 by Ts tan of P by 2. But the value of Ts is not given in the problem, so assume Ts is equal to 1 second. So it is equal to 2 tan of 0.2 pi by 2. So its value is 0.65. Next is similarly, it is equal to 2 by Ts tan of, again it is 2 tan of 0.6 pi by 2. So it is equal to 2.75. So thus specification of analog filter are, it is equal to 0.8, it is 0.65, AS is 0.2, and it is equal to 2.75. Next is step 2. So step 2 is calculation of order of filter. Calculation of order of filter, that is we have to find the value of n. So it is given by n is equal to 1 by 2 into log of divided by 1 by AP square minus 1 log of by So we have to substitute here values. It is 1 by 2 log of 1 by 0.2 square minus 1 divided by 1 by 0.8 square minus 1 log of, it is 2.75 by 0.65. So half of log 24 by 0.5625 divided by log of 2.75 divided by 0.65, that is equal to 1.3. So thus approximately n is equal to 2. Now next is step 3, calculation of cutoff frequency. As omega c is not given, so we use equation, it is equal to, we use this equation because omega 2 is not given in the problem. So it is 0.65 by 1 divided by 0.8 square minus 1 raised to 1 by 4. So its value is 0.75. Next part is calculation of the poles of Hs. Step 4, calculation of poles of H of S. So the poles of Hs is given by, for this we have to use this equation, plus minus e raised to j to n plus 2k plus 1 pi to n, where k is equal to 0, 1, 2 dot dot n minus 1. So it is equal to pk plus minus 0.75 e raised to j into 2 plus 2k plus 1 pi by 4. So it is plus minus 0.75 e raised to j into 3 plus 2k pi by 4. Now here the range of k is from 0 to n minus 1. We write here range of k is from 0 to n minus 1 and n is equal to 2. So value of k, therefore value of k is equal to 0 and k is equal to n minus 1, that is 2 minus 1 is 1. Now for k is equal to 0, it is p0 is equal to plus minus 0.75 e raised to 3 pi by 4. So it is plus minus 0.75 cos 3 pi by 4 plus j sin 3 pi by 4. So it is p0 is equal to plus minus 0.75, it is minus 0.707 plus j. So it is p0 into plus minus, multiply this 0.75 with this bracket, it is minus 0.53 plus j 0.53. Therefore p0 is equal to minus 0.53 plus j 0.53 and 0.53 minus j 0.53. These two are the rules. Now next is for k is equal to 1. It is p1 is equal to plus minus 0.75 e raised to 3 plus 2 pi by 4. So it is equal to plus minus 0.75 to j 5 pi by 4. Therefore P1 is equal to plus minus 0.75 cos of 5 pi by 4 plus j sin of 5 pi by 4. Therefore P1 is equal to plus minus 0.75 minus 0.707 plus j So these two are the values for k is equal to 1. Now the location of these poles we have to show. This is sigma, this is j omega. This is minus 0.53, this is plus 0.53. This is j 0.53, and this is minus j 0.53. So it is so these four poles. This is P0 0.53 minus j 0.53. This is P1 0.53 plus j 0.53. This is minus 0.53 plus j 0.53, and this is minus 0.53 minus j 0.53. Now we know that the stability, next is we know that the stability, the poles which are at LHS of the S plate should be selected. So we write here for stability poles which are at LHS left hand side of S plane should be selected. Thus we select poles minus 0.53 plus j 0.53 and 0.53 minus j 0.53. Now these poles are complex conjugate of each other, so we will denote the poles by S1 is equal to minus 0.53 plus j 0.53 and complex conjugate is minus 0.53 minus j 0.53. Now next is step 5. It is calculation of HS. Now the transfer function of analog filter is H of S is equal to S minus S1 of, therefore H of S is equal to 0.75 square divided by S plus 0.53 minus j 0.53 So we simplify this equation, we solve it. It is 0.75 square divided by, we multiply these two brackets and the answer is S square plus 0.6 S plus 0.56. Therefore H of S is equal to 0.56 divided by S square plus 0.06 S plus 0.56. Next is second part of the problem. Obtaining transfer function or for digital filter. Now we have to use the bilinear transformation method. Then Hz is obtained by putting for BLT, that is bilinear transformation method. Hz is obtained by putting S is equal to 2 by Ts Z minus 1 by Z plus 1 in equation of H of S. So we have assume Ts is equal to 1 second. Therefore H of Z is equal to 0.56 divided by S square is 2 by Ts. So 2 its square 2 by Ts. So we directly write it is 4 into Z minus 1 by Z plus 1 square plus 2 into 1.06 into Z minus 1 by Z plus 1 plus 0.56. So again we solve it and we get H of Z is equal to 0.56 into Z plus 1 square by 6.68 Z square minus 6.88 Z plus 2.44. This is the required transfer function to design the digital filter.